We will be solving this question, which is construct quadratic tree. So let's begin. If you look at the problem description, so it's not clear, and you might not feel like reading the whole question just because it's too lengthy and not clear as well, right? I will take an example and I will explain you the whole question, and then I will move towards the solution. Okay, so let's see the board. So according to the question, I will be given a matrix of n cross n size, where n will be 2 to the power x and x can be in the range of 0 to 6. In short, it's a perfect matrix. Okay, so using this matrix, I have to construct a quad tree. Before moving to the approach, let me explain. Let me tell you what is a quad tree. A quad tree is a simple tree, but with four nodes. Suppose this is a child node, and this child node is called top left. The first one is top left. The second one is top right, and the third one is bottom left. The fourth one is bottom right. I will explain each and everything, what is top left, top right, bottom left and bottom right. Okay, and while constructing a quad tree, I have to keep in mind few things. There are some steps. Okay, so what is top left here? Suppose you are given a matrix like this. Okay, this is the matrix. Top left represents this area. I mean, first you will find the value, what will be the value of this root node, and after that you will find what will be the top left node and top right node and bottom and this. So while finding the root node value, you will simply use the whole grid like this whole grid. Okay, but while finding the value of top left node, you'll simply use this portion only this portion, top left. Okay, and this one you will use sorry, this is top right. You will use this portion to find the value of top right. Similarly, this one for bottom left and bottom right. Okay, I hope you got this. So the question is how we find what will be the value of a node, right? Suppose you are given this grid. Okay, and in that grid, okay, let's take this example only. Okay, if you see the whole matrix, there are few zeros and there are few ones. So it simply, I mean, there are both zeros and ones in the grid. Okay, so for this, if there are both zeros and ones, then the root node value can be anything, and there is a second variable as well, that is leaf, and it represents either the current node is a leaf node or not. So if there are mixture of both zeros and one in the grid, then it's not a leaf node. So let's take this example, and I will try to explain you what will be the value of the node. Okay, so this is the node. Since there are both zeros and ones, and I can, at this condition, I can either say let the value is 1, or else I can say the value is 0. And is it a leaf node? No. Why? Just because there is combination of both zeros and ones, right? So both of the node is acceptable. You can have 1 also, you can have zeros also. And if let's say this is a grid given to you like this, where every value is a 0, so for this, what will be the root node? Root node will be such that the value of root node will be 0, because every cell is having a 0 and easily will be true, because it's a leaf node, because every value is a 0 here. It could be 1 as well. Okay, if the matrix is like this, 1 here, 1 here, and 1 here, and 1 here, then the node would be like this, 1 and true. Okay, it's a leaf node. Okay, that's why. So I hope you got this, how we have to construct a root node. Okay, so now let's take this example and construct a quadtree so that it gets into your head. Okay, so I will check. So now I am given this matrix. Okay, I will first check what are the number of zeros and what are the number of ones in this portion, okay. So let's not count. Let's say roughly there are 1 2 3, I mean there are few zeros and there are few ones. Okay, so it will, I can just I can mark the value as 1 or I can mark the value as 0. Let's mark the value as 1. And is it a leaf node? No, it's not a leaf node, so I will say F, false. Now I will construct the child node for top left. Okay, I will go to this portion. How I determine that this will be the top left portion? I will simply divide this. I mean, it's a perfect matrix, right? So you can simply think of this, what will be here. So if you look at this portion, the every value is a 1 here, so it will be what? It is a leaf node, and the value will be what? 1, and what is leaf will be true here. Okay, now let's find what will be the this was top left, now this will be top right. Okay, this one will be top right. Let me write it here. So if you look at top right, we have both zeros and ones, so it will not be a leaf node. I can what will be the value? I can do it anything. So let's say 1 is a leaf node. No, false. I will find again I will go into this. Now I am solving for this part. Okay, I am solving for this part. I have to again find the top left child for this root node. Okay, I will go to this, I will find the top left, and if you see this portion, every value is a 0, so I can simply say 0 and true, because it's a leaf node. Now let's say this is top right, and if you see top right, every value is 0 here, so 0 comma true here as well. Top left, top right, bottom left here. Now it's bottom left. If you see bottom left, every value is 1, so it will be 1 comma t. And if you see bottom right, then it is also same, 1 comma t. Every value is 1, right? Every value is 1 in this portion, so yes, it's a leaf node. Now we solved for this. Now we'll go to top left, top right, bottom left of this whole matrix. Okay, this whole matrix. So what will be the bottom left? This one. Look at this portion. Every value is a 1 here, so I will say 1 comma t, simple. This was for bottom left. Now for bottom right, what will be? Every value is a 0 there. This is bottom right. Okay, every value is a 0, so I will say 0 comma true. It's a leaf node, right? So I hope you got how I have to construct a quadtree. It's very simple. I just have to know that what are the number of zeros and ones in my matrix portion, and then I can simply construct the quadtree out of it. So I think it's very simple. I don't need to. Okay, let's see how I can decide from where to where I have to count the number of, I have to count. Okay, so let's see this as well. Okay, so let me move it down. Right, erase this as well. Now if you see, then what I have to do is that currently n is what? N is, for this matrix, n is what? N is 8, right? 1 2 3 4 5 6 7 8, and here also 8. The n is also here also 8, and here also 8. Okay, erase this as well. I have to find the root node value. So what I will do is that I will check each and every cell. I will check each and every cell, and I will get the what is the number of zeros and ones, right, out. Okay, now suppose I want to find what will be the what will be the, I want to find the top left root node. Okay, I want to find the top left node. I have to go there. I will be doing this using recursion only, but how do I make sure that I just count this portion of the matrix only? I just count this portion of the matrix only. This is something I have to do, right? Okay, so it is also simple. So if you closely see, like in each root node, my each child is getting a half of it. Like this is top left, this is top right, and this is bottom left and bottom right. The parent the parent matrix was of n size, n cross n. The child matrix is of n by 2 into n by 2 size, right? Each child is of n by 2 into n by 2 matrix size. Okay, so I can I can take use of this and try to calculate the number of ones and zeros in our matrix portion. Okay, so I will simply use this. So n is 8 currently, for the whole n is 8, and let's say I am taking another thing for that, like I also want to know, right, this I also want to know what is my from where I have to start, right? Suppose this is a matrix, this can be also a child of any node. Okay, I want to know, right, I just can't know after out of n from where I have to count. I want to know the starting point of starting row and starting column, this cell, so that I can start counting from here, and I will go from here like this, right? For example, if you took this and if you push on this, I will start the counting from here. I need to know this, so I will say row and column. This is row and this is column, and as n is 8 only. Okay, for now row is what? 0, and column is what? 0, because I will be for finding the root root node, I will be counting from here. Okay, I will start the counting from here. I will start from here and I will move down down down. So the row is 0 and column is 0, this portion. Now you want to find the top left. Okay, you want to find the top left. What will be the top left node? So for that, what will be, how the R, C and N is going to change? Okay, let's see. For top left, okay, TL, what will be the R? Let's say R dash. R is not going to change here if you closely see. Like earlier on, this was the portion of our root node. Now this will be the portion. Only what will be changed is that my n is going to change, right? So I will say R1 R dash is equals to R, C dash is equals to C, and n is equals to n by 2, right? Now let's see what will be the change in top right while finding top right. This is top right. Okay, if you see, then R is not going to change, it's same, but the column is going to change. R is not going to change, but the column is going to change. How is going to be the change in the column? C dash equals to C plus n by 2. What is n here? 8 by 2 is 4. So I will say C dash is equals to C plus, C is what? 0 plus 4, it's 4. C dash is 4. 0, 1, 2, 3 and 4. Yes, it's correct, right? And n equals to n by 2. N by 2 will be same for every, okay, every child node. Top left, top right, and it's now for bottom left. What will be the change in R1? If you see, then there will be change in R1 only, there will be no change in column. What will be the change in R1? It will be R plus n by 2, right? It is increasing. R value is increasing by n by 2. And what will be the change in C1? C dash, I mean nothing, no change. C dash is equals to C only, and n equals to n by 2 only. Now for bottom left, now for bottom right, what will be change? Right, earlier on you were here, right, and now this is the change. The row value is also increasing by n by 2 and the column value is also increasing by n by 2. Rho dash is equals to R plus n by 2 and C dash is equals to C plus n by 2, n equals to n by 2. Okay, right. So let's see some of the base cases for the recursion as well, right? I hope you got this, how I am saying this, all this formula. Okay, suppose currently my R and C is this portion, right? I am considering about this portion only. Okay, let's say I have a 1 here. Okay, so for this, what is R? What is the value of R? R is 0, but what will be the value of C? C will be, it will be 4. And what is n? N is simply 2 here, nothing. N is simply 2, right? Now if you try to find the top left guy, if you try to find the node value for top left guy, how my formula is going to change? R dash equals to R and C dash equals to C and n equals to n by 2. Now n will be what? 1. And top left guy means this portion only. Now at this position I can simply return what? I can simply return the node with a value 1 and with is leaf will be true in this case, right? So this is the best case. I hope you got all this. Now it's time for coding. It's very simple actually. Let's say int n is equals to grade dot size, right? I want to know. Okay, I will be making a function, helper will be helping me and it will return the node. So I will say return helper. I have to pass the grade and the row, column and n as well. Okay, row, column, the n as well. So what is row and column first? 0, 0, and the n is what? N. Simple. Okay, int r, int c and int n. Okay, now there was a base case if n is equals to 1. If n is 1, right, here our n became 1, and what we did was that I just returned a node with a value of that R and C, I mean matrix of R and C. Okay, if n is a 1, I will simply return new node, right, and with what will be the value of that node? Grid of R, C. Okay, and isLeaf is what? True, right? Now if it is not the case, I have to find the number of zeros and ones. Int 0 is equals to 0, int 1 is equals to 0. Okay, initially both of them are 0. For int I is equals to, I will start from I and I will go till where? I is lesser than R plus n. simple. I think it's also simple. I don't need to explain this as well. I plus plus for int j is equals to c, and j is lesser than c plus n, right? J plus plus. If grid of I comma j, I mean ij is a 0, I will say increase the value of zeros, else ones. Now you remember, if there is every value of that cell is a 0, then I have to do what? I have to return the node with the value 0, and isLeaf will be true in this case. So how do I find that every value is a 0 or 1? So first, suppose I want to find is every value 0. So if every value is a 0, then the number of ones will be 0 in that case, right? So if ones is a 0, then what I will do is that I will return a node, and that value, the value of that node will be what? 1, because so ones is 0. Okay, sorry, the number of ones in that portion is 0. It simply means that the whole portion is filled with 0, right? So I'll say 0 and isLeaf what? True. If it is not the case, then there can be another one also, 0, where zeros is 0. The number of zeros are 0. It simply means that I have to return what? If there is not even a single 0, then it simply means that the whole portion is covered with 1. So I will say 1 and 2. If both of them is not correct, so I have to, it's not a leaf node, I have to find the child node for that root node as well. So I will first construct a root node, simple. So I will simply name it as a root node, new node. I can simply name it, I can simply give a value anything, whatever I want, and isLeaf will be false in this case because it's not a leaf node, right? For this, root of top left, okay, I want to find for top left now, is will be what? Helper and grade r. How r is changing in top left? This is how r is changing, but let's okay, r c n is changing by how? N by 2, okay. And top left, top right, helper, grade, r is changing how? R is same, c dash equals to c plus n by 2, c plus n by 2, and n by 2 will be the n for, okay. Root bottom left now, helper, same, grade, r is changing how? R will be changing like r plus n by 2, r plus n by 2, and c is also same, n by 2, okay. Now bottom right, grade, in this case both of them are increasing by n by 2, and n by 2. Now at last I can simply return root. Right, I think I have done each and everything. So if you see the time complexity for this, it's not but what can be the size? Okay, let's discuss what will be the time complexity. Okay, the space complexity will be O of n, and not n only, actually log of n, right? And log n can go in maximum can be 64, right? so it's very less. Space complexity is almost like O of 1, right? Nothing there. And time complexity is also not much, but O of n into n for log n times, right? O of n for log of n times. Space complexity is also O of log of n. Let's try to run this. Some mistake, okay. Oh, okay, new keyword I didn't added. I should have. Oh, so let's submit the solution. Submitted. So I hope you guys understood the whole solution. If you have any doubts, you can just post your doubt in the comment section. I will definitely reply to that comment. Thank you for watching the video.